Okay, last video from lesson 4.4, and we're going to practice. Hopefully, you've had a chance to dig into some of the new material that we covered. I put up here to help us out our special triangles, and hopefully, you have those. I know you have those in your notes somewhere. You can reference those. It's our 45, 45, 90 triangle, our 30, 60, 90 triangle. I've written them up here in radians because I think we're going to need more help remembering those angles in radians, but I hope you can see them up on the board. So we're just going to put together all of the junk that we covered in this lesson and be able to practice a few. I'm on page 544 in your textbooks, and I'm looking at example 7. It says use reference angles to find the exact value of each of the following trigonometric functions. And first one they give us is sine 135 degrees. So supposedly I'm able to tell them exactly what sine of 135 degrees is. I definitely haven't memorized that, but let's give it a look. If I wanted to think about where 135 degrees was, I think I need a darker marker than that. Since we're in degrees, that makes life a little bit easier. I have an angle in standard position. 135 is greater than 90. It's less than 180. It's somewhere over here. (135 degrees). All right. Again, I don't have that memorized. They want to find the sine of 135 degrees. Here's what I know. I can use a reference angle to kind of work with right triangles again. And my reference angle would be this angle here. And I'm hoping this one is simple enough you guys can tell me my reference angle real quick, or how do I find it? I know that this whole thing is 180 degrees, so I would do 180 minus 135, and I get 45 degrees. So sine of 135 may be the same as sine 45 degrees. Here's the only thing I have to remember that might be a little bit different. Over here, let's say 45 degrees is over here in the first quadrant, and I know it's going to be, sine is going to be positive in the first quadrant. In the second quadrant, I just have to remember, is sine positive or negative? That's the only way it might be a little bit different. But if I remember a smart trig class, or if I remember that sine is the y value, it's still positive over here. In fact, sine of 45 degrees and sine of 135 degrees are the exact same thing. Using a reference angle, and it happens to be that 45 degrees is a pretty good angle to use because I've got these special triangles. Here's 45 degrees. Sine of that is opposite over hypotenuse, 1 over root 2. Which we're going to clean up. Root 2 over 2 is exactly the sine of 135 degrees. I came up with that using the reference angle, which was 45 degrees. And you can go ahead and put your calculator in degrees mode and ask your calculator, hey, what's the sine of 135? It will give you its best approximation. This is actually a more exact answer. It's the most exact answer we can come up with. So if you can come up with that on your own, that's a pretty good deal. Root 2 over 2. All right. Next one that they give us, find the cosine of 4 pi over 3. Now, maybe part of the trick again is figuring out where is 4 pi over 3. I know that halfway around 180 degrees is pi radians. This is 4/3 pi. It's a little bit more than pi. So I'm guessing my angle is going to terminate over here. My angle in standard position is going to run all the way past the 180 degrees or pi into the third quadrant. And so my reference angle is going to be this angle here. And I'm going to find it by taking this angle minus this angle. This angle here is 4 pi over 3. This angle over here is pi. Halfway around is pi. And so I'm going to find my reference angle just by doing that. Hopefully you're well practiced in that by now. I'm going to need me a common denominator. And I'm hoping you guys are able to get there and be able to do that. But 4 pi over 3 minus 3 pi over 3 is pi over 3. That's going to be my reference angle. I can find the cosine of 4 pi over 3 by looking at the cosine of pi over 3. It's going to be the exact same except for the sign, the SIGN sign. In the third quadrant here, a smart trig class, cosine is not positive over here. Again, I can remember that cosine, if it were a unit circle, cosine represents the x value, and that's negative. So I'm going to look for the cosine of pi over 3, but I have to remember to throw a negative in front of it. That's going to be the one other thing. Well, pi over 3 is one of my special angles again. And so I'm here. I'm going to find the cosine adjacent over hypotenuse. The cosine of pi over 3 is 1/2. And so I know that the cosine of 4 pi over 3 is going to be the same value, except the only difference in the first quadrant, this is a positive 1/2. Over here, it's a negative 1/2. That'll be the only difference. So I knew exactly what the cosine of 4 pi over 3, you could put your calculator in radians. You can ask it that. It's going to give you that exact number because it's not an irrational number. And it makes you pretty smart. You're able to find that out without asking your calculator. Last one, they want the cotangent of negative pi over 3. All right, let's have a look at that one. Seems a little trickier. Cotangent, make sure I got that right, of negative pi over 3. I have an angle in standard position, but it's a negative angle, so it's coming down this way. And it's coming down pi over 3 down. This angle down is also going to be my reference angle. All right. Fourth quadrant is actually pretty simple. We could go about this the long way. We could say, let's add 2 pi to this and come around and find a positive 1 and then subtract that from 2 pi. I'm just telling you, I hope this makes sense to you. If I came from here down pi over 3, then that's exactly what that angle is, pi over 3. It's just that, remember, my reference angles are always positive. So I want to find the cotangent of pi over 3. Well, again, let's go to our special triangles. pi over 3, tangent is opposite over adjacent. Cotangent will be adjacent over opposite. So cotan of pi over 3 is going to be adjacent over opposite 1 over root 3. Which equals root 3 over 3. Hopefully that's not too packed in there. You can see that. That's the cotangent of pi over 3. Now the only thing is I have to determine here in the fourth quadrant, is my cotangent going to be positive or negative? Smart, trig. Actually, here tangent and cotangent are positive. Class. Here, cotangent is going to be negative. So I'm going to put negative root 3 over 3. I'm going to double check with the book and feel good that it gives that answer, and it does. I'm going to ask you to practice some more of those. Now, at the bottom of your notes page, there is homework questions. Listen, hopefully you're still listening. I would prefer where it says, actually, I'm going to change it before I send it out to you, so no worries. We're going to do number 3 through 83 in multiples of 4, and we'll check in, make sure to write down any questions that you might have. Thanks.